think we can get started. This is Elizabeth Pendergrass, and I'd like to welcome you all to today's webinar, Best Practices for IT Portfolio Budgeting. Before we get started, I would like to make you all aware of a few technical items. All of you who are listening on the presentation are currently on mute. So to ask a question at any point during the presentation, just use the Q&A dialog box shown on the right-hand side of the WebEx screen. Doug will field as many of these questions as he has time for at the end of the presentation. If he does not have time to answer any of your questions, don't worry, he will respond to all of these via email. And he will also provide his contact information for any further questions you might have. I'll start by quickly introducing our presenter today, Doug Putnam. Doug is Co-CEO at QSM and has 35 years of experience in the software measurement field. His responsibilities include management and delivery of QSM's software measurement services, defining requirements for the Slim suite of tools, and overseeing research projects derived from the QSM database. So without further ado, I'll let Doug get started.
Thank you, Elizabeth. So today I'm going to spend the next hour talking about our IT portfolio budgeting solution. And it's my hope that you'll come away with one or two good ideas that you can apply in your organizations that will make you a little bit more effective at this whole process of IT budgeting. It's a simple diagram which sort of lays out the various stakeholders that are involved in this IT budgeting process. So on the left-hand side, we've got our business. They're full of ideas, new things that they want to implement that's going to make their operation more efficient, more profitable, and they've got a limited amount of money that they have that they can put towards implementing these solutions. On the right-hand side, we've got our IT organization, and it has certain facilities, number of people, technologies that are available that enable them to address the needs of the business. And in the middle, we've got sort of our technology and business executives, which are responsible for trying to roll all of this information up and do a balancing act between the resources that they have on the IT side and the demand for capabilities that are coming out of the business and their responsibility for managing the resources and the cost at the overall corporate level. So in our particular IT budgeting solution, we want to be able to address the needs of each one of these various stakeholders as we work our way through that process. So how this game often is played out is in the arena of the annual budgeting process, where we come together and we have to provide information about the various projects and the priority around those projects, and be able to provide that so that we can address the corporate needs to do their pipeline management, their financial management, their resource management, and risk management. But often this whole process takes place in a fairly short time window, and there's lots of pressure to come up with these budget numbers. Usually there's minimal information where we're trying to make fairly significant decisions. Unfortunately, the results get locked into commitments that quicker than you can imagine. There's a lot of political sensitivities, some that are visible, some that are invisible, that surface as this whole process goes on. And there's often no consistent way at which the organization's approaching their estimation of the various projects and the budgets that they're coming up with. So it makes it for a challenging environment, and but it's one that we think that there are some relatively good solutions for. So how we implement this particular practice, our solution anyway, is it's sort of a five-step process. The first thing that we want to do is we want to understand in terms of the existing budgeting process for the organization, we need to understand where decisions are made and what information is available at those various decision points. And then what we want to do is we want to take and make our tooling responsive to the input information that we have and the decisions that need to be made. Once we've established that and we have our tooling infrastructure set up and ready to go, then we're really into the actual process of building out the initial estimates, which the budgets are constructed from. Sometimes in that step, we are simply reverse engineering estimates that have already been done by project teams. And in some cases, we're actually developing those estimates from scratch. And in most cases, we find that it's sort of a combination of those activities. What we hope to come out of that process is that we're going to be able to identify any projects that are extraordinarily risky or extraordinarily wasteful. And so in doing that, we're going to trap the projects where we have opportunities to save money and opportunities to eliminate disasters. When we have cases where they're either extreme at risk or extremely wasteful, usually we'll go through some kind of adjudication process and make sure that that everyone feels comfortable with adjusting those in an appropriate fashion so that they reflect the capability of the organization and the reality of the situation. Once we've gone through that process, then we'll move into taking those basic the data on the projects and rolling those up into a portfolio assessment. We sort of take it in a three-step process. The first one is start with the as planned portfolio, as submitted before any adjudication has taken place. So that kind of gives us the opportunity to look at the number of projects that were at risk or the number of projects that were wasteful. Second stage is to actually, so that gives us kind of a baseline of where we started. The next stage is to make adjustments for risk and waste so that we think that the estimates better reflect the capability of the organization. And then the final step is to address the needs of the executive decision makers and try to make that portfolio conform with whatever resource and or financial constraints that they might be faced with. That process may go through 2 or 3 or 4 different iterations, but eventually we'll end up at a point where we feel like we have something that's a decent portfolio and a budget going forward. And then if sometimes there's a need to pass some of the more detailed information on specific projects into a corporate PPM system for resource allocation and the like, and we have a mechanism that allows us to do that. It's mostly useful for the project managers and such, as they can get allocations of actual skilled people against resource requirements that they have. So let's take a minute and just talk about step 1, our infrastructure setup. So our whole goal in setting up our tools infrastructure is we want to make our estimation process the negotiation between the business and the IT technical people as objective and fact-based as possible. So what we do is we try to get our tooling dialed into their particular development environment. So that might mean, having a good understanding of the methods that are being used, the platforms that are being developed on, product lines, application domains. We want it to be able to speak their language with the kinds of things that they're doing. So there's 3 main areas that we want to get a handle on. The first one is scope. Our tooling is based on a scoped-based estimation process. That really gets at what is it that we have to build to implement the capability that the business is interested in. So we'll talk a lot more about this in a few slides, but we want to try and work with the artifacts that are available at the point in the process where we have to do this analysis and decision making and be able to make them be as relevant to our solution as possible. The second thing that we're interested in is finding out what it takes to produce a certain amount of scope. So we do this by establishing some trend lines based on schedule and effort. How long does it take to build a certain amount of functionality? How much effort does it take? Those sort of become our ground truth for what's capable and helps us identify risky and wasteful situations. And then the third thing that we want to do is we want to be able to understand how our resources are going to be allocated to the project over time, so that as we start to roll up our portfolio, we have a skills profile of what skills we're going to need, how many we're going to need, where we might run into bottlenecks and the like. So the process of how we get these three main areas pulled together is we do sort of as our starting point, we do a basic data collection on recently completed projects. Try to get somewhere in the range of 8 to 15, the more the better, obviously, and we try to make them be as representative of the class of work that we're going to be focused on as we can. In each one of these various projects that we collect the data on, we want to try and capture multiple sizing metrics. And the idea is we want to be able to take whatever we have and be able to translate it into other artifacts that we might need to support our estimation process. And we also want to be able to possibly triangulate our answers using multiple sizing artifacts. And then we'll capture the schedule and effort as well. So in terms of our scope estimating and our sizing data, when we, in many of the instances where we've been involved in the dialogue between the business and the technical teams about some capabilities that they want in their next sort of cycle of budgeting, we're going to be dealing with things that are at a fairly high level of abstraction. So on the business side, you hear things like maybe scope statements or high-level scope statements or business requirements. These are the sort of things that are relevant to their world. On the technical side, you might hear things like themes or epics if it's an agile shop, or you might hear technical requirements, or you might hear use cases, and these are the way that they've taken certain information and tried to translate it into a world of something that they understand. And ultimately, they're going to produce some lines of code or implementation units, which is sort of a combination of lines of code and package configuration steps that might be involved in building a system, or it might be function points or whatever. So what we like to be able to do is to take the data in these multiple dimensions. So in this case, I have a graph of the number of business requirements and the number of function points that were produced. We build a graph, we run a statistical analysis and do a curve fit, establish a relationship between these two along with some variability, and it becomes an algorithm that if we know the number of business requirements, we can predict a number of function points, or we can predict a number of lines of code within a certain range of uncertainty. And if we can do that for one or two or three of these different metrics, it gives us a better handle on the scope that has to be built. And we're working with units that both the business understands and the technical team understands. How we might use that information is we might just build a simple calculator. So here's an example on the top. We've got our use cases, business requirements, and those are the two primary elements maybe that we're able to capture information on. We've done our curve fit. We have an algorithm. We input the number of use cases. We input the number of business requirements. Our algorithm calculates the number of implementation units. It also calculates the number of function points that we might have. If we have a language gearing for the function points that we're going to produce, then we can use the function points to estimate implementation units. And we have a range of values which we might expect. We can average that together along with a measure of uncertainty between the high and the low. It gives us a way that we can use information that's available at the budgeting time and translate it into some other size metrics. We might have some customers that feel more comfortable with doing a detail level of sizing maybe with their use cases. And so we can build some methods which allow them to identify from a population of this many use cases, they might have X that are very small, some that are small, some that are medium, some that are medium large, and very large. And we have different gearings which will allow us to calculate a size based on how many of each of those categories they have. So it gives us a way that we can work with their units, get some sizing, and get a good handle on how much functionality we have to build. The second area that we want to focus in on is our trend lines. So I sort of think of these as kind of like ground truth for performance. You know, in the past, each one of these points up here represents the amount of time that it took to build a certain amount of functionality. And again, we can fit a curve fit through the middle, so we have an expected schedule and some variation. But we can also identify areas that seem like they're unrealistic. So if we have an estimate that falls down into this zone down here, it's probably something that has a very low expectation of being able to be achieved. On the other extreme, we've got some that are wasteful. And so we could have projects that are estimated up in here, and there are opportunities to probably save some money. Same thing for person months of effort. So these become a great way that we can trap unrealistic scenarios really early in that initial negotiation between the project team and the business. Final thing that we want to do is get a feel for how the skills, and this really plays more to our resource management aspect of the portfolio planning, but how the skills are going to roll on and roll off a project as a function of time. And so we may have several different methodologies that might have different skill sets. We might actually have to build out a couple of different profiles or templates that will represent those. But there's some logical way in which people skills are going to build up and ramp off of a project. And so we want to have a way that we can capture that and be able to use it in an intelligent fashion. We find that the way most estimates that we see in this budgeting process are in today's world are simply a list of how many hours are being allocated for different skill categories. So we have these 5 different or 6 different skill categories, and here's the hour estimate for each one, and it rolls up to a certain amount of hours. But it doesn't, this view of the world doesn't tell us how those hours are going to be spread over a timeline and where they build up and where they tail off on a project. So we think it's important that we have this view that rolls up to these numbers over here. It does a much better job in terms of our resource planning for the individual project and also for the roll up at the portfolio level. So we have some nice ways within our tooling where we can identify the various skill categories, assign a labor rate, and then build the profile for how those skills as a percentage of the total effort are going to roll on and roll off the project. We can have a boxcar load that has just level of effort for various activities. We can have a buildup that peaks early and ramps down. We can have one that peaks more towards the end. We can increase or decrease the various activities. We can essentially model just about anything that happens. So it provides a whole nother level of sophistication to the resource planning and the portfolio budgeting. So those would be our configurations and our setup to get us in a position where we can do the estimates. So in our release estimating process, how this typically goes is there's some activity where we have our business and our IT teams that come together and start to discuss the scope of capabilities that they want to have done. And it might be in their scoping statement or business requirements or whatever. The IT team sort of looks at those things. They may do some task-based estimating. They might do some role-based estimating. Maybe they just do some guesses. Who knows? Sometimes it's a mystery. Might be some expert judgments. But if they do an estimate and they can provide, based on the scope, they can provide an hour's estimate, and we can get an estimate of the time frame. A lot of times they won't have estimated the time frame. Maybe the estimate comes from the business. We want to have this in 5 months. In any event, we can reverse engineer those numbers very quickly, and then we want to test those for reasonableness. Do they fall outside of our trend lines? Are they down in that unrealistic expectation area? And so right away we can sort of trap high-risk programs early and start to work towards more reasonable expectations. If no estimate exists, then we're going to start with something that we'd call a trend-based solution. Let's start for the scope that we've identified, let's start in the center of your database. It's a safe solution. And then we can play out other scenarios, adding people, reducing people, changing productivity assumptions if those are warranted, so that we can get something that more accurately reflects the nature of the constraints that are being imposed on that particular release. And then finally, we want to put both of these solutions under configuration management so that we can produce our as submitted and our adjusted, risk adjusted solutions later on when we do the portfolio roll-up. So here's an example of just a basic estimate of a trend-based solution. So let's say our determination of our scoping statements give us an effective size of 12,000 IUs. We come in at 12,000 IUs, go to our effort trend line. Each one of these little dots represents our historical projects, our average fit, and we come in at our schedule on the average fit, and that produces an 8-month time frame with a peak staffing of around 14 people and about 1,500 person days. There's our trend-based solution, center of mass. Now we may have a situation where the team says, we don't have that many people, I need to hammer this down to 10 people, in which case we'd pull the head count down and stretch the schedule somewhat, and maybe our person days would drop a little bit and our schedule would go a little longer, and we'd sort of test to make sure that they don't exceed crazy boundaries, and that's how we'd arrive at a solution based on a starting point for a trend-based solution. A lot of times when we go through the reverse engineering of the estimates, we're going to come up with the high risk scenarios. So again, we have our agreed to scope, and maybe we have our estimate from the IT group, which was a role-based estimate. And when we position that up against our effort trend lines, it looks reasonable. It doesn't look like it's ridiculous. It's right close to the center of mass. We feel good about it. But maybe our business has a desired schedule of 3 months, and when we try to impose that 3-month schedule with this many hours, we get something that looks very risky, very short schedule outside the bounds of our historical data. And then when we build a staffing plan that consumes this many person days over 3 months, we get a staffing plan that looks really unrealistic. You build up to 30 people and tail off over 3 months. So it's an impractical solution that just screams for change. And moreover, if they staff up like this and they don't make this schedule and they slide closer to up here, that means they're going to be chugging along at 30 people for another 4 or 5 months, and they have, double the cost of their program in terms of an overrun, which wreaks havoc on the budgeting. The budgeting scenario at the portfolio level. So we want to capture these things as early as we can and start to look for more reasonable types of scenarios. So now we're at the point where if we've gone through all of that analysis on our individual projects, we want to start to roll things up at the portfolio level. So here's a snapshot of what a sample portfolio might look like. It's broken down into 4 sort of major product areas. There's an area for workflow automation. There's an area for package implementations. There's some back office capabilities that are being built, and there's some IT transformational program that's ongoing. So each one of these bars up here represents the schedule for one of these given systems. On the left-hand side, maybe we've got 20 to 25 projects that are represented here. And over on the right-hand side, we have on the top right quadrant, we have a staffing plan in the form of a stacked bar graph. So each one of these color codes is a project, and the staffing that's required, or at least assumed in the estimate that's provided for this particular scenario. Down below, we have the cumulative cost, in dollars for each of those guys. So, I mean, you can look at it quickly. You can see, hey, the portfolio peaks at a staffing of around 218 people out here in the fall of 2017. We can see that there's like, 1, 2, 3, 4 major projects that are sort of driving the major amount of costs that's associated with this portfolio. And then there's some smaller projects that are sprinkled in as well. So it just kind of gives us a view at the portfolio level. Now, if we want to start to look at risk and waste from a portfolio level, we use these what we'll call quadrant charts with bubbles, where each bubble represents a individual project. The size of the bubble reflects the relative cost of each of these projects in the portfolio. So the bigger the bubble, the more that they cost. What I've got is I have a dimension here, which is schedule and productivity. And on the schedule, I'm looking in terms of standard deviations from the trend lines that I showed you earlier. So right here in the center, I'm on the average of the trend line for schedule. If I move in this direction, I'm going shorter time, and in this direction, I'm going longer time. And likewise, over here, I've got a productivity trend line, and this is the average productivity from the data set. And these are assuming higher productivity up here and lower productivity over here. Now, the shaded area I would set as an acceptable variation around my trend line. And it's set, in this case, to plus and minus 1 standard deviation. So 68% of the historical data points have fallen within this boundary zone. And that's where I'd like my projects to operate. I don't want them operating out on the fringes of what's been seen before, both from a risk standpoint or a wasteful standpoint. So the bubbles that are up here in this portion of the quadrant are the ones that I'll call at risk. They have a high productivity assumption and they're being done in a short schedule. They're the projects that are at risk of not executing and giving us a portfolio overrun. The projects that are down here have a very low productivity assumption and are taking a lot of time, and they might be the ones that are wasteful. If there's no dramatic reason why they're down here, why shouldn't they be operating up closer to what we've done historically? And the same thing over here for effort. So this is our effort deviation and productivity, and the same thing. We have some projects that are risk at effort and some that are wasteful from an effort standpoint. Nice thing is we can sort of look at this one and say, well, that big bubble right there is probably this guy. That's a really low productivity assumption and it's a lot of effort. That's a wasteful project. Maybe we can do something about that. So it gives us one nice way that we can sort of view the portfolio, staffing and cost, and also see our projects that are at risk and our ones that are wasteful. Now, when we identify those outliers, those are the ones that we really want to potentially target for a reconciliation. One criteria for entering this reconciliation is it's just too far outside of our target zone. We don't feel comfortable. We want it to be moved closer in, or at least we want to understand why it is where it is so we can make an informed decision about whether that's reasonable or not. The second might be that we have a big difference between our team-based estimate and our tool-based estimate. And so we need to have a dialogue where we bring those two closer together, or at least understand why they're so far apart. And then the final one might be if we were just doing quick feasibility estimates, we might have a program that's very strategic, it's very important, and it requires maybe a deeper dive so we can improve some confidence around the numbers that are built into our budgeting process. So the adjustments that we'll make are really going to be focused on looking at the productivity assumptions, revisiting our sizing and productivity assumptions, looking for if there's any specific relevant historical data that would give us more confidence in the assumptions that were made, or if there's some really unique circumstances that would justify making an adjustment in the productivity either higher or lower. And then there might also be some better information about constraints. They might be, cost constraints or staffing constraints or schedule constraints or release packaging types of constraints. And so maybe those can be brought to bear that'll shape a solution that's a little bit better and moves us towards hopefully something that'll fit our target zone. So as we go through that adjudication process, hopefully at the end we'll come up with some official position. The official position might be we agree to disagree and we're going to accept some risk. That's okay, as long as we've gone through that process and everyone's in agreement that that's the official position going forward. It might be that we move in one direction or the other. Maybe a team might say, yeah, I think maybe your estimate's a little bit better. I'm going to move in this direction. It might be the other way around. It might be that we find some common ground in between. But it's important to go through the adjudication process to make sure that everyone feels like we're doing the best job possible to reflect the reality of that portfolio. So then we enter into our assessment phase. So the typical scenarios that we want to do is first we want to look as submitted. As they were initially submitted, what does it look like? The important part of this is it gives us the ability to identify risk and also identify potential savings. And so that's an important aspect of the whole process is what's the value added that we've provided as part of going through this process of evaluating the portfolio and reducing risk to the organization. So once we do that and we have an adjusted portfolio for risk and waste, that really sort of gives us what we think is a portfolio that's optimized to the capability of the organization. So the next step then is to engage the C-suite, the C-level decision makers, and say, okay, here's our portfolio that we think matches what our capabilities are. How does it match your funding levels, your resource levels, your risk tolerance? And so we start to look at reshaping the portfolio to address the needs of the executive decision makers. So here's in our example, we'll go back and here's our as submitted portfolio. And here's certain information. So I've got one graph on the top left here, which is our cash flow. It's our spending rate, and it's broken out by project. So, at peak spending out in this time frame, it looks like we have a peak spending rate of about $2.2 million a month. That corresponds to a staffing of about 218 people and a total portfolio budget of about $54 million with a fair number of projects at risk and a few wasteful projects. So what do? We want to attack each one of these at-risk and wasteful projects to try to come up with something that we think is more reasonable. So we can sort of bring up our list of various projects. We can sort of highlight an area and see which of the projects are which. We can come in and attack these one by one and adjust the productivity and or the staffing assumptions and instantaneously see the impact of the change of that one project to the portfolio. And if we do that and work our way through the process, we'll end up with something that maybe looks like this. So we've taken each one of that projects that were in the cluster of at-risk and we've moved them down more into our target zone. And we've taken our wasteful projects and moved them up. And you can see that this project was that SAP Financials application. It's much smaller slice now. It turns out that as we've made these adjustments, it's changed our peak headcount and it's changed our peak spending rate. Everything now is sort of loaded up, happening early. We have a much higher peak. Now we're building up to about 260 people at peak staffing, and we may have a capacity limit of 225 people. So for a good 6 months, we're in excess of the capacity of our IT organization. And maybe we're up at a burn rate of about $2.7 million per month at our peak load. But the nice thing is by moving these projects down increased our cost, but moving these projects that were wasteful up decreased our costs. So the net result is that there was more savings here than what we had in terms of our overages for the other. So we end up with a net benefit of reducing the cost by close to $10 million on that portfolio. Now, when we run into cases like we don't have the capacity to take on the projects, then we have to do some adjustments to the portfolio. So, the typical adjustments that we might be involved in would be possibly eliminate projects or maybe defer them to the next fiscal year. Sometimes that's not an object, sometimes it can be deferred. We can slip the start dates provided the projects aren't underway, so maybe we push them out a quarter, or we can look at adjusting staff up or down, accelerating or decelerating. We might have some options by having some staff augmentation contractors or outsource partners where we can leverage them on an as-needed demand basis, and we can bring them in, and at least we would know where we would like to exercise that option for those particular programs. So here's a case where we've gone back and tried to optimize the portfolio for this capacity limit. And it turned out that we had to take 5 projects and slip them to the right by 3 months. And we needed to take our 3 projects that had the biggest staffing and reduce those by 5 or 6 people each. And in so doing, we've been able to reduce our capacity limit down to 225 people and get our cash flow now down to about $2.2 million. And by actually reducing the head count, we get some savings on the portfolio, and that reduces us down to closer to $40 million. So now we might go through this process 2 or 3 times to try and get it organized just right for the decision makers, but it gives us a way to at least try to work within the constraints that they have to operate within. As we're playing those different scenarios out, we're always logging these various solutions into our solution repository so that we can say, hey, here's where we started, 54 million. Once we adjusted for our capability that we think is more relevant for our organization, we're down to 44. Once we optimize for staffing and schedule slips, now we're down to something like $39 million. And we end up in just about the same place that we started from a schedule standpoint. So it gives us an ability to kind of show the changes and the cost impact of the changes that we make to the portfolio. So in terms of supporting the information needs sort of at the corporate level from a resource management standpoint, what we're doing is we're identifying giving them the ability to identify when resources of various skill types are required, and I'll show that in just a minute. We're going to give them the ability to play out scenarios that are better optimized for their resource allocation and provide them information at both skill categories at both the project level, product line level, and portfolio level. So here's just a sample of what some of those views might look like. So here's just a head count at the portfolio level, undifferentiated by anything. Just here's our staffing requirement for that portfolio. In this case, we break it down by our different product lines. So this is our staffing for the transformational programs. These is our staffing for our back office programs. These are our implementation packages. This is our workflow analysis. So it gives us the staffing at a program level, or at least a grouping of project level product lines, value streams, what have you. Here's our staffing by individual projects. And then here's our staffing by the roll-up of our skill categories that were built up in each one of these projects. So we have our project management resources down here. This is our architects. Now our architects are right in here. These are our technical leads. These are our business analysts. These are our developers, and these are our enterprise service folks. So we can quickly see, like, okay, here's our peak demand for developers is back in this time frame. Our peak demand for business analysts is out in here. Gives us a feel for what the skill breakouts are, where those people are needed for this portfolio of projects. From a financial support, financial management support, we're able to quickly play out and compare financial scenarios at the portfolio project and product line level. We can look at total estimated costs, we can look at total hours, we can look at spending rates, we can look at hour per month expenditures, we can do that by total or by labor skills, and do it monthly by labor skills as well. So here's an example of the financial views. So here's a cash flow profile by individual project. Here's a cash flow profile by individual skill levels. Here's a total cost by project. Here's a total cost by our skill levels. So just a feel for the kinds of information that we can have available at the roll-up level. To support resource demand, we can predict the demand for our IT resources, enabling better our ability to take our demand and better match it with our capacity and get a better balancing out. We can look at demand by skill levels. We can identify where our peak demand is. We can identify where new projects can be added to the pipeline based on our capacity constraints. And we can play out what-if scenarios to balance those demand and capacity. So in this case, when we start to tail off here, this is our ability to take the difference between this point here and wherever our tail off is our ability to take on new projects. We can look at where we have peak demand for various skills and whether that's going to be an issue for us and a bottleneck for our development organization, or whether we even have the skills that we need in that area based on the current portfolio plan. In terms of risk management, we can use our trend lines very effectively early in the negotiation between the business and the IT group to identify risky expectations and smoke those out right away. We can use that as a forum to sort of look at alternatives so that we get a more realistic expectation right off the get-go. We can evaluate the risk profile of the portfolio using those quadrant charts and the bubble diagrams. And we can play out alternative scenarios, which will reduce risk and potentially give us a better cost or schedule scenario. So the bubble charts give us a way that we can, take two dimensions. And here I'm just showing productivity and schedule, but we could take any number of various combinations of these variables and position our charts up here. But the idea is we can pick what we want. We can look at quadrants that are going to be risky and quadrants that are wasteful, and we can look to optimize those. We can also do some sort of probability analysis on that portfolio by taking each one of the projects in the portfolio and identifying it as a green project. We feel like we have a very high probability that we can execute this project given the estimate that we have for schedule and effort. Yellow, there's a little bit more uncertainty that we'll be able to execute under our estimate of schedule and effort, or red, we have a higher degree of uncertainty in terms of our ability to execute that project with the assumptions that are implied. And if we sort of have different amounts of variation associated with this might be plus or minus 10%, this might be plus or minus 30%, this might be plus or minus 50%. We can run a simulation which says, well, as our as submitted portfolio, expected value $54 million, but with all the uncertainty in the yellows and the reds and the greens, we feel that there's a high probability that we will not exceed 60 million, like a 93% probability that we can execute this portfolio as planned for $60 million or less. But there's also a very low probability that we would be able to execute this down in the 40 $45 to $49 million range. So it gives us a little bit of probability protection, which is useful from management reserve planning at the C level. So it's another sort of independent but useful mechanism for looking at the uncertainty associated around a portfolio. If we get to the end of our analysis, everything's good, we might have some project managers that want to move their skills estimates as a function of time over into a PPM system. So we have a framework that's built into our Slim tool, which is a PPM integration framework. It requires an adapter to move into your PPM system, which just sort of syncs up your system with our framework of how we're pumping stuff up. We have one that's built commercially for the for CA PPM, Computer Associates PPM system, and it allows the two-way interaction of passing of information back and forth between our system and the PPM applications. I mean, this is most value, it seems like, to project managers that need to take their estimates and get them into a PPM system and then be able to say, who are the actual people that are available that map up to the skill sets that I need on my program at the time that I need them. Just in summary, I think the benefits of this solution that we have for our IT budgeting is once we get our tooling dialed in, we've got our historical data pulled together, we've got our sizing methods established, we've got our skill categories built up, and normally we can get that all and get the historical data put together. Normally that's maybe a 1 to 3 week process, depending on how efficient our customer is at sort of getting things organized and set up. It makes the whole process really efficient on the stakeholders' time. They're providing normal information that's part of their existing business process. We're looking at their scope statements, their business requirements, their use cases, whatever it is. We're then put in a position where we can start to do, everyone agrees on scope. Now we're looking at what can we accomplish time and effort-wise, staying within our trends, and try and keep this as objective as possible. If we find that we have disconnects, we're identifying those early, and we're starting to look at potential solutions before we get to the point where it's already been budgeted, locked in place, and a disaster waiting to happen. So by using that process, we feel like we've got pretty good transparency on how that all takes place and everybody's on board. It gives us the ability to rapidly look at alternatives, both within the project and the portfolio scenarios. Sometimes this process is so onerous and so difficult that by the time we get to the point where the organization's built their initial budget, they're exhausted, worn out, and can't even think about looking at an alternative scenario. And that's really where I think this solution shines. Once we've got that stuff in, we start manipulating our productivity assumptions, our staffing assumptions. We're moving start dates. We can get we can start to do some pretty good analysis and talk to the issues of the executive management in the company. So in general, I just think it takes a little bit of pain out of the budgeting process. So there you have it. That's our solution. That's how we implement our budgeting process. I hope that you've found it to be some useful information, and hopefully you can take away 1 or 2 good ideas. At this point, I'm happy to entertain a few questions in the remaining time that we've got.
Okay, and just to let everybody know, we will have a replay available, so if you came in late or if you want to share this with anybody else, I will be sending out the link to the replay next week. So just to start off, we had a question about how do you decide the use case size?
How do we decide the use case size? Well, so we're looking at, you mean in terms, I'm not sure I exactly understand the question. You mean in terms of like the small, medium, large, very large? If that's what we're talking about, there we're looking at actually the threads that we go down in the use case, and we're taking some samples. So the customer is telling us, well, here's a relatively small use case, and we'll look at that actual use case, and we'll take a medium one, then we'll take a large one, and we'll see like the number of threads that they're actually going down in their use case scenario. So it's an empirically determined thing based on the customer's artifacts and their description of what they see as small, medium, and large.
Is the solution available in a SaaS model?
I would think that any of the types of analysis, the statistical fitting analysis and other things that I were doing were pretty straightforward regression analysis that could be accomplished in any statistical analysis package, SAS, Minitab. Frankly, you could do a lot of it in Excel. So it's, it doesn't take a super amount of high-powered, statistical analysis package. So in terms of doing that, in terms of the resource planning and that that was done specifically in our SLIM tooling at both the project level and at the portfolio level. SLIM Estimate, our single release estimator, and SLIM Master Plan are sort of portfolio level aggregating and what-if tool.
How does QSM validate the estimates that go into the annual budget?
So I think, the way that we typically do that would be, as I mentioned in our portfolio, we're always trying to use the empirical historical data of the organization and position those estimates against it. It's either going to be within a reasonable boundary or it's not. And if it's within a reasonable boundary, then we feel good about it. From a sizing standpoint, a scope sizing standpoint, if we can have more than one method that's applied and they're all confirming one another, that gives us a lot more confidence in our sizing input. And so for us, it's really just a few inputs. It's our scope size, our productivity, and the number of people. We pop those in, we position it against a trend line. If it falls outside the zone, our standard deviation zone, then it tells us that that's, in an area that hasn't been seen before very frequently. So there has to be a good justification. There has to be some practical reasons of why they would be able to operate at that level. It would have to be, hey, we've got the best people on our organization that are working on that particular small team. They've got ideally suited tools. It's a relatively straightforward project. Those would be justification. But if it's just, well, we're using the same team that we did before, but now we're going to be 10x more efficient, that doesn't cut it.
Can you please tell us what version of SLIM and Master Plan you were using in this presentation?
So in this presentation, I was using our 10.0 version of SLIM. That would be the version that has the portfolio roll-ups of staffing by project and also has the bubble charts. So right now we're in our final stages of testing that release, and we've been sort of using it in our consulting practice tentatively with our 9.0 version just to make sure that it's behaving well as part of our testing process. So 10.0 should have it later in the year.
This person says that they spent a lot of time on labor planning. Does the tool also have functionality to estimate infrastructure, software, hardware, and service contract costs?
We have a template for infrastructure and a good way to handle infrastructure. We have some customers that use SLIM to estimate hardware projects, mostly in the chip area. So it's mostly designed for estimating design type projects. So it's not just purchasing hardware and that sort of thing, but if you're designing specialized hardware, we just need to tailor the tool to talk the sizing language of that design discipline, and we can build a template, and we can do the same skills profiling, and we can build historical trend lines. Those are all possible.
Where does QSM get the percentages to break out the cost and effort by role?
We get that from as part of that data collection activity. Sometimes we're pulling directly from a PPM system where they actually have the labor by month, by role, and we can get a pretty good, and we just get a roll up of what it is. So then it's just go in and work with our percentages until we get it till it matches up exactly. And if we do have that information, we're generally looking at hopefully multiple projects to see how much variation we typically get, so that we don't just model it after one project that maybe has a atypical kind of a distribution of skill categories. So we try to get it empirically. If we can't get it that way, then we're usually sitting down with one of the project team, the project manager, after the fact. He's given us a time, he's given us an effort, and we're starting to say, okay, do we have the right shape of this curve? Does that fit the way that you actually did it? And if you had to look at the roles that you had, where were those people phasing on and phasing off? So it would be a little bit more of a, sort of their experience, to the best of their recollection type thing. But I think it's usually a pretty effective way to get in the ballpark, and a decent method when you don't have the explicit hours by month for each one of the skill categories.
Once the projects are in play, does QSM have a way to track each project?
Sure. I mean, I only talked about the estimation components of our Slim Suite, but there's also a control aspect where we can take the estimates and start to capture either weekly or monthly the actuals against that estimate, and we can replace the estimate with the control project, so that we can be sort of adjusting the portfolio based on the actuals and forecasted end date based on the actual experience to date. So if there's additional requirements, growth, or other kinds of things that are changing how the performance of a particular project, we can capture that dynamically and forecast the impact to the portfolio and to the individual project.
How long does it take to put an estimate together at the release level? And how long does it take at the portfolio level?
So depending on the level of the estimate that we're doing and whether we've gone through that infrastructure setup, it might be as easy as we take the number, we look at the document that the business comes in with, and we say, how many scope statements do we have? We put that in our sizing algorithm. We run a trend-based solution, and in 15 minutes, we have an initial estimate. If it's one where we're doing a little bit more deep diving, we've got to dig down a little bit more into the sizing artifacts and maybe work with the project team a little bit more, or we've got various conditions and constraints. It could be, several hours or maybe up to a day to do, a routine, estimate of a little bit more complicated project where we don't have the artifacts, readily available to us. But it can be as easy as, really, it can be as simple as if they know the process and they know what they're expected to bring and they already have that stuff pre-processed, it can be, a 15 to 20 minute exercise. And maybe we're spending most of our time, or maybe a couple hours, but we're spending most of our time looking at alternatives and helping them find a workable solution for both that's going to satisfy both the business and the IT group and come to some agreement on that.
Okay, I think we have time for just one more question right now, and I know there's a few questions we haven't gotten to, but we will respond to all of those individually after the presentation. And please feel free to contact us with any additional questions you might have later. So the last question is, how much of the customer's own historical data is needed to successfully implement this annual budgeting process?
Well, I mean, the simple answer, I guess, is the more the better. Like I said, normally we'll target for the 5 or the 8 to 15 or whatever it was. It can be done when we don't have any historical data. But then we're relying on maybe industry trends for an application domain. And I think what you open yourself up to is the people who are going to be more skeptical are going to say, well, we're different or we don't match up to that industry trend line. So the more that you have that empirical evidence, the more bulletproof your arguments and negotiations are going to be going forward. So, you can get away with, maybe 5 to 10. It's always better when you have a little bit more. It's always better too when they're distributed over an entire size regime. I mean, you want to have a few small ones, you want to have some medium ones, you want to have some large ones and very large ones, and that way you're sort of covered the whole base of project types that you're going to run into.
Okay, thank you very much, Doug. This was a great presentation, and stay tuned for future webinars from QSM.
Thanks, Elizabeth.